Hello, this is Mark Malaki. I'm an Enterprise Solutions Specialist with Dell. Today I'd like to discuss the EqualLogic Frameless or Virtualized Architecture. When you look at many SAN solutions today, many of our competitors have a frame-based SAN. With EqualLogic, we have a frameless or virtualized architecture. When you start looking at a frame-based architecture, what you basically start off with is a frame. You have to sit down and you have to decide for the next 3 to 5 years how much data growth, how much performance, the types of features, functionality, etc. that you need. And with a frame-based SAN, that usually comes as a specific model number, and that specific model number of a SAN that you purchase can grow to a specific amount of drives. So as an example here, you start off with dual controllers for redundancy and performance and a number of disks. With EqualLogic, we also do the same thing. We start off with dual controllers and a number of drives, and this is your basic SAN. So right now the frame versus frameless, or the competitive architecture versus EqualLogic, doesn't look that different. So let's grow that frame-based SAN. As months go by, you need to add more disks for capacity or for performance. So we go ahead and we add more drives. Now with the EqualLogic array, when you're ready to add more drives for capacity and performance, you not only add disks, but you also add 2 more controllers for cache, throughput, and performance with your disks. If you look at the chart below, now what's going to happen here is as you add more and more EqualLogic arrays, your performance and your capacity will scale more linear than by just adding disks or spindles to your SAN. And then if you've planned out your capacity or performance requirements for 3 to 5 years, you've just purchased your SAN. What happens if you're acquired by another company, you acquire another company, or a new application comes online, compliance, video surveillance, anything to that effect? Now what happens with your frame-based SAN is you've now actually added all the disks and all the spindles that you can to your frame-based SAN. What this means is there's no way to actually continue to grow with your frame-based SAN. If your frame-based SAN in this example grows to 60 drives, you've filled those 60 drives up. Now you need that 61st drive. You need to buy another frame-based SAN, and that's a forklift upgrade. However, with EqualLogic, what you're going to see here is today with EqualLogic, you can have up to 16 physical EqualLogic arrays, and you can manage those as a single storage system. So whether you have one single EqualLogic array or 16 EqualLogic array, you manage that EqualLogic environment the same way. So ease of use and scaling is still going to be the same from day 1 or day 365 or even 3 years from now. Also, what you're able to do is these 16 physical EqualLogic arrays, some of them can be solid state drives, some of these can be SAS drives, SATA drives. It doesn't matter. Every single physical EqualLogic array is called a member, and multiple EqualLogic arrays or multiple members fit into a EqualLogic group. What we also do is you don't have to worry about provisioning and RAID types. Once you select the RAID type per EqualLogic array, EqualLogic or the EqualLogic array or the member will take care of the provisioning, the hot spares, the movement of data, etc. So as you see this is whether you have one physical EqualLogic array or member or 16 EqualLogic array or members, you basically are working with a single pool of storage. And from that single pool of storage, what you're going to do is create volumes. So these volumes 1, 2, and 3, you would map these as physical drives or drive letters to a Windows server. So volume 1, 2, and 3 could be drive E, F, and G to your local Windows server. Also, if we talk about virtualization, as an example with VMware, volume 1, 2, and 3 could be mapped as data stores or connected as data stores to your ESX servers. So again, with your frameless architecture, our virtualized architecture for SANs, whether you have 1 or 16 EqualLogic arrays, you manage that the same way. And the same thing is not just for management, but also when we look at the pool of storage. And with our automatic load balancing and tiering, what you're able to do is these volumes can move from one physical array to another physical array, and because of our virtualized architecture, the physical server or virtual server doesn't care what physical array these volumes are on. During production, you can have these volumes on high performance, low capacity 15K SAS arrays and solid state SAS arrays. And then later on, as you look at compliance with archive and keeping data around longer, it might not necessarily need the production type of performance, but we still need to have it readily available. So these volumes can actually automatically tier themselves, and they can move from solid state and 15K SAS drives to 10K SAS drives and to SATA drives. So you can have EqualLogic take care of the movement of data, or you as the network administrator can simply click on these volumes and say move it from one RAID type to another RAID type that's on separate or distinct drives and different EqualLogic arrays.